Hello learners, today we cover the topic of IEEE 802.15.4 connectivity, network connectivity thing. How do we use the in our IoT network of IEEE 802.15.4. My name is Pravesh Kumar. Here is my Gmail ID. Now we start this topic by introduction, then we talk about the architecture, then we talk about the its type and how do we use in IEEE 802.1.5 in our IoT net connectivity and various and other various network like Zigbee and other thing is based upon the IEEE 802.15.4 concept. How do we use them? Firstly, the introduction of this network thing is that it has low data rate and less power consumption and extended lifetime of the this network. It operates on ISM band. ISM band stands for industrial, scientific and medical band. It in ISM band various bandwidth is allotted to it, like it for 250 kbps speed we require 2.4 gigahertz, and for 40 kbps we required 915 megahertz, and 20 kbps at 868 megahertz frequency allotted to the ISM band. Then for modulation, in the modulation we use DSSS modulation. What the DSSS stands for, it for sequence stands for direct sequence spectrum. It has one of the most features that it reduces the overall noise to the signal spectrum. So if we have various noise network, then we use to DSS to remove the noises from the network. It highly tolerant to the noise interface offer link, and it also offers the reliability to the our network. For the various speed we use the BPSK and OQPSK. BPSK stands for binary phase shift queuing. OQPSK for higher data rate stands for offset quadrature phase shift queuing. We use CSMA CA carrier sense modulation avoidance, carrier avoidance for our network. Then we multiplex allow multiple users to nodes interferences. For 802.1.5.4 we use the star and mesh topology in our network. These are the basic things we use and feature of 802.15.4 network. Then we talk about the architecture. In the architecture there is only two basic sublayers: the basic layer, physical layer, PHY stands for physical layer, and MAC layer. In 802.5.4 there is two basic layers stands for this network, and other two layers are stands for to specify as SSCS for service specific convergence sublayer, and LLC for logical link control. These two layers connected to the upper layer of network model, like network layer and session layer and application layer. This contact to the upper layers. Only two layers are specified to the 802.15.4 spectrum. Now it has two types like non-beacon enabled and beacon enabled. How we use the non-beacon enabled and beacon enabled, and what these things do in the our network. For we talk about the beacon enabled network. It has periodic transmission of beacon message like periodic transmit it data frames and via slotted CSMA with super frame structure managed by PAN coordinator. PAN coordinator means our personal area network. The beacon used this beacon enabled network used for synchronization and connect interface to the other nodes in their discovery frame. Now we talk about the non-beacon enabled network. How we use what is the non-beacon enabled network? These data frames sent via unslotted CSMA. In the beacon enabled network, we have a slotted CSMA CA, but in the non-beacon we have a unslotted CSMA CA. Beacon used only for link layer discovery. Here the non-beacon used for link layer discovery. It had decentralized communication amongst them. There is no centralized system to connect the discovery. It have decentralized. It connect to another network. It connects to another network. It connects to another network. Now it has two network nodes we specify. There is FFD and RFD. FFD stands for full function devices like PAN coordinator. It creates the PAN coordinator do. It creates the personal area network and it creates the our personal area network and connect to each our network, and then there is a router. What it is do? Router has a create the routing table and flow and control device like in computer network. With these two things do FFD and communicate the devices to each other. Now we talk about the reduced functional devices. What is it? Has low feature of FFD. For a it has reduced function, so it is less than the FFD. So we use the less RAM and CPU RAM required, less utilization of our resources. It has low power consumption. It can talk to the FFT. If we have to, there is RFT and we have to talk to the FFT, we it simply call to the this function. Now thank you for listening to me and subscribe my channel for more videos.